To watch your fascination in news headlines is always fantastic. Most of us certainly have many theories, ideas, and imaginations regarding the galaxy and space, and scientists are always trying their level best to explore the mysterious cosmic world. And just like that, our fascination to peek into other galaxies has become reality. It broke every record in the sector of space technology. Philosophers and scholars have pondered the beginning of time since human enlightenment, even attempting to pinpoint when everything began. Only in the current era of astronomy comes close to addressing that question with a reasonable degree of assurance. Researchers have discovered what they believe to be the farthest astronomical object yet discovered, HD1, a galaxy candidate estimated to be 13.5 billion light-years away. That's an incredible 100 million light-years farther out than the nearest galaxy, GNZ11. Here are the basic questions that arise. How can you confirm the existence of a distant galaxy? When doing surveys involving thousands of galaxies, it is usual practice to first extract photometry for each source in every available filter, and then, surprisingly, use this photometry to estimate each source's redshift. Observed quantities such as apparent magnitude can be translated into physical quantities once the redshift is understood like luminosity. These photometric redshifts are quick to obtain, but not as accurate as spectroscopic redshifts, which can only be determined from a high-quality spectrum of a given galaxy. Spectroscopic observations always require far more observing time than imaging per galaxy because the observed light is dispersed across the detector. According to the most widely accepted cosmological models, the universe began 13.8 billion years ago with the Big Bang. This approach corresponded with the cosmic dark ages. Astronomers are still unsure about what the early universe looked like. As a result, astronomers continue to test the limits of their instruments to determine when the first galaxies formed. Here, we are starting with the big breaking news that astronomers have peered out into the vast expanse and spotted what they think is the farthest and oldest galaxy ever observed. On April 7, 2022, astronomers announced the discovery of the farthest astronomical object ever observed. They think it's a galaxy, and if it is, it's the most distant one yet discovered. HD1 is the name of the object. It's at a distance of 13.5 billion light-years. Looking out into space is the same as looking back in time, since light does not travel infinitely quickly and requires time to travel across space to us. So, these astronomers explained, we're gazing at this object as it was 300 million years ago, immediately after the Big Bang, when our universe was founded. This distant object was discovered by an international team of astronomers using a variety of telescopes. For a total of 1,200 hours, the Subaru Telescope, Vista Telescope, UK Infrared Telescope, and Spitzer Space Telescope all peered at the same location in space. They used the Atacama Large Millimeter or Submillimeter Array, aka ALMA, to confirm the distance after they identified the dim red object. GNZ11, a galaxy in the direction of Ursa Major, held the previous record for most distant objects. GNZ11 is 13.4 billion light-years away with a redshift of 11.09. It's been 400 million years since the Big Bang, yet it still exists. However, HD1 shines brightly in ultraviolet light, indicating that the galaxy is teeming with activity. As a result, scientists speculated that it could be a starburst galaxy or one that generates stars at a rapid rate. First, the galaxy could be producing stars at a breakneck speed. These could be the very first stars in the universe. These early stars would be classified as population 3 stars by astronomers. Because they've never been spotted so far back in time, population 3 stars are a hypothetical category. They would have been huge, hot, and brilliant stars that generated chemical elements heavier than hydrogen for the first time. HD1 is thought to be producing more than 100 stars per year, according to scientists. This rate is more than 10 times that of a typical starburst galaxy. One of the reasons they believe the galaxy isn't creating regular stars is because of this. The galaxy has been given the moniker HD1 by its discoverers, and it is shrouded in mystery. Scientists are unsure if the galaxy is a starburst galaxy, which is churning with star formation, or a quasar, which has a large, active, supermassive black hole at its core. However, subsequent examination revealed that the galaxy candidate traveled more than 100 stars every year, 10 times the rate of typical starburst galaxies. Researchers have proposed 2 new theories to explain the galaxy's high energy output. On the one hand, it could feature a supermassive black hole at its center that is 100 million times the mass of the Sun. This would be the oldest black hole of that scale yet discovered. HD1 could, on the other hand, be home to some of the universe's very first stars, which scientists have yet to see. Other galaxies appear to be redshifted as the universe expands. The greater the distance in space-time, the higher the redshift. Astronomers can use this effect to calculate how far light has traveled to reach us. The multinational team of astronomers has broken the cosmic distance record of the farthest galaxy ever seen in the universe, which was held by NASA's Hubble Space Telescope until now. Hubble's sharp eyes discovered GNZ11. GNZ11 is a strikingly brilliant newborn galaxy, shown as it was created 13.4 billion years ago, only 400 million years after the Big Bang. Let's talk about this galaxy for a bit. In the constellation Ursa Major, GNZ11 is a high redshift galaxy. GNZ11 was the oldest and most distant known galaxy in the observable universe until the discovery of HD1 in 2022, with a spectroscopic redshift of Z equals 11.09, corresponding to a proper distance of around 32 billion light-years, or 9.8 billion parsecs. The galaxy's redshift is so high that its angular diameter is smaller than that of certain galaxies with lower redshifts. This signifies that its angular size is bigger than its size in light-years. The researchers utilized Hubble's Wide Field Camera 3 to spectroscopically determine the distance of GNZ11 as well as the redshift caused by the universe's expansion. The discoveries, which were published in March 2016, revealed that the galaxy is further away than previously thought, and that it is at the limit of what the Hubble telescope can see. The Hubble Space Telescope, which was launched into low Earth orbit in 1990 and is still operational, is a space telescope. It is not the first space telescope, but it is one of the largest and most versatile, regarded as a critical scientific instrument, as well as an astronomy public relations boon. GNZ11 is roughly 150 million years older than the previous record holder, EGSY 8P7, and was discovered quite close to the end of the so-called dark ages of the universe and near the very beginning of the universe. GNZ11 is a quarter the size of the Milky Way galaxy, has 1% of its mass, and is producing new stars at a rate of 20 times that of the Milky Way. With a stellar age of 40 million years, the galaxy appears to have created its stars very quickly. The existence of such a large galaxy so soon after the first stars began to form defies several existing theoretical models of galaxy formation, and now another record-breaking accomplishment. The James Webb Space Telescope of NASA has set a new record by detecting the light of a star that lived inside the first billion years of the universe's formation in the Big Bang, making it the farthest individual star ever seen. The discovery represents a significant step back in time from the previous single-star record holder, which was discovered by Hubble in 2018. That star existed when the universe was around 4 billion years old at a time, known as redshift 1.5, according to astronomers. The term redshift is used by scientists to describe how light from faraway objects is stretched or shifted to longer, redder wavelengths as it travels toward us as the cosmos expands. JWST will be able to look back to the first light glows that appeared after the Big Bang, as well as determine which theory explains HD1's ultraviolet glow, and maybe even find far more distant galaxies in the beginnings of the universe. This brings us to the end of the video. Hope this video was able to boost your excitement level as the eyes of human technology has continued to expand its vision. And if you enjoyed watching, do like this video. Don't forget to subscribe to the channel for more insightful content from us. We'll see you in the next one. Until then, peace.